Let us see the force exerted by the jet on the plate. Now, as seen in the figure, the force exerted by the jet on the plate can be calculated from the impact of jet, that is impulse momentum principle. We know from the Newton's second law of motion, if we see the force exerted by the jet on the plate in the direction of the jet is given by rate of change of momentum in the direction of the force. So the rate of change of momentum is given by the initial momentum minus final momentum upon time. Hence the force is given by initial momentum is mass into initial velocity minus mass into final velocity upon time. Now here it is the force exerted by the jet on the plate. So the initial velocity is higher and the final velocity is lower. Hence there is a you can say the force is transmitted from the jet to the plate. Hence it is taken as initial momentum minus final momentum. If it is taken as final momentum minus initial momentum, then it will come as a negative, and that negative sign will show you that the force is exerted by the plate on the jet. So here we want to find the force exerted by the jet on the plate. So you have to take it as initial momentum minus final momentum. Hence Fx is equal to, you know, that is mass per unit time is m dot into initial velocity, that is v1 minus final velocity v2. Okay, in x direction. Now when the jet is striking, in this figure if you see, when the jet is striking, we are interested in finding the force in horizontal direction, that is x direction, Fx. So we will consider the velocity in x direction only. If you want to find the force in y direction, then you will consider the velocities in y direction. Now for velocity in x direction, the initial velocity before striking the plate is v for the jet. After striking the plate, the velocity of the jet in x direction will be 0. There will be no further motion of the fluid from here onwards. That's why the velocity at this point after striking, the velocity in x direction will become 0. Hence it is final velocity is 0 and initial velocity is v in x direction. While for y direction, the initial velocity is 0 because there is no velocity in y direction, and the final velocities are divided into two, one is going upward and one coming downward. So we are not interested in finding the force in y direction, but we are interested in the force in the direction of the jet, so in x direction. That's why we will consider only the velocity in x direction. So let us see from the formula, that is Fx is equal to mass per unit time into initial velocity minus final velocity. So we know that is the mass per second or mass per unit time, it is given by rho av, that the formula we know, rho av or rho into q, that is density multiplied by discharge, will give you the mass flow rate, or rho into area into velocity will also give you mass flow rate. The velocity of jet before striking is capital V minus velocity of jet after striking is 0. So V minus 0, and Fx is equal to rho a v square. This is very important formula. This is giving you the force in x direction. Now let us immediately see the numerical on the first case. So find the force exerted by the jet of water of diameter 75 mm on a stationary flat plate when the jet strikes the plate normally with a velocity of 20 meter per second. Now it is given that the diameter of the jet is 75 mm. So it's a 0.075 meter, and the area you can immediately calculate pi by 4 d square. So you can get area also. We now having the ready-made formula, force is calculated by rho a v square. So you put all the values, rho as 1000, area you have calculated velocity 20. You will get force is equal to 1000 multiplied by 0.00 into 4417 into 20 square. That will be giving you the force in x direction as 1766.8 Newton. So this is the force exerted by the jet on the plate for stationary vertical plate. So this is very simple numerical. Let us immediately see the next numerical on the same, that is the stationary vertical plate. Water is flowing through a pipe at the end of which a nozzle is fitted. The diameter of the nozzle is 100 mm and the head of water at the center of nozzle is 100 meter. Find the force exerted by the jet of water on a fixed vertical plate. The coefficient of velocity is given as 0.95. Now here first we have to write the given data. The diameter of nozzle is given as 100 mm. Okay, so you can write it as a 0.1 meter. Now head of water H, capital H, is 100 meter. What do you mean by this capital H? Now we know that in case of dam, the potential energy is converted into kinetic energy. So you know that the relation between the velocity and the head. So here the velocity can be found as under root of 2gh, where h is the head of the water, okay, above the center of the nozzle. So it is 100 meter, okay, that is the height of water coming through the pipe, okay, to the nozzle. So the velocity, theoretical velocity of jet, okay, coming out of the nozzle is given by under root of 2gh, okay, so it is 44.294 meter per second. But it is also given that coefficient of velocity is 0.95. We know that coefficient of velocity takes into account the losses occurring in the nozzle, and that is given by actual velocity is given by coefficient of velocity multiplied by theoretical velocity. So actual velocity will be 95% of the theoretical velocity, which is 42.08 meter per second, and hence the force on the fixed vertical plate can be given by force is equal to rho a v square, where rho is 1000, a is area of jet, which is calculated as pi by 4 into 0.1, that is the diameter is 0.1 meter, so 0.1 square is equal to 0.007854 meter square. So rho a v square again gives you the force exerted by the jet on the fixed stationary vertical plate. It is coming as 13.9 kilonewton. So it's say very simple numericals are there. Now let us see the next case, that is the force exerted by the jet on the inclined stationary plate. For inclined stationary plate, if you see the plate is, in this case the plate is inclined one. Now this is very interesting case. Initially in the first case it was a vertical, now it is inclined. So it is inclined at an angle theta as given in the figure. Now this angle theta is very important, that is the angle of inclination. Because of this angle theta, if you see the figure carefully, this angle will also be theta, this angle will also be theta. Hence this angle which is shown in the diagram, that will be 90 minus theta. So this will be 90 minus theta. So this angle is very much useful for us in calculating the force exerted in x direction for the inclined plate. So now if you calculate the force in x direction, now directly you can't calculate the force in x direction, because when you are striking the jet on the plate, it is going in upward direction and downward direction also, but now they are having some component in x direction also, that is x direction component for upward going fluid also and downward coming fluid also. In the previous case there were no x components, so now you have to take care for calculating fx. So what they have done to calculate fx, they have considered first fn. Instead of calculating fx, we have to calculate the force normal in the normal direction to the plate, and then you can resolve that force, normal force, along x direction, okay, by taking fn cos of 90 minus theta. You can calculate fx as shown in figure. So first you have to calculate fn. How to calculate fn? Now here this is the plate and you have to take the normal direction. So normal direction is this to the plate. So what you will do, now this will be the same case as of that the jet is striking to the plate in normal direction, okay, as of the previous case it is striking to the vertical plate, okay, in perpendicular direction. So you can treat at this case as of the previous case, but you have to resolve this velocity in normal direction for calculating the force in normal direction to the inclined plate. So how will you resolve this velocity? So velocity, you know, this angle is theta, and this angle is, this velocity is moving in x direction. So in x direction the velocity is v. So what will be the velocity in normal to the plate direction? So if you see this velocity component, one will be this component and one will be this component. So this component, okay, along the plate it will be v cos theta, and along the normal it will be v sin theta. So v, if you resolve along normal direction to the plate, it will be v sin theta, and v sin theta will be striking on the plate in the normal direction. So if you apply now the impulse momentum principle for normal direction to calculate the normal force Fn, so Fn will be equal to the initial momentum minus final momentum upon time. So the initial momentum, for calculating the initial momentum, you will consider the velocity as v sin theta, and for calculating the final momentum, again the velocity will be 0 because it is a fixed plate. So in this direction there will be no velocity in x direction. After striking, the velocity is coming in this direction. That's why the velocity in normal direction after striking will be 0. So if you see the formula to calculate the normal force, that is equal to the rho a v into bracket the initial velocity v sin theta minus 0. So rho a v is the mass flow rate and it is v sin theta minus 0, final velocity, initial velocity minus final velocity, which is 0. So it is rho a v square into sin theta. So the normal force is coming as rho a v square into sin theta. Now we know that the normal, once you calculate the normal force, you can easily find the x directional force, that is fx, okay, or as well as you can also calculate the fy, that is vertical force. So fx, to calculate fx you have to take fn into cos of 90 minus theta. So if it is the same thing is done here, so fx is equal to fn cos of 90 minus theta. So fn sin of theta, cos 90 minus theta is sin theta, hence it is given by rho a v square sin theta into sin theta, which is coming as rho a v square sin square theta. So fx is coming as rho a v square sin square theta, and fy is coming as fn into sin of 90 minus theta, and it is coming as fn into cos of theta. But fn we know it is rho a v square into sin theta, hence fy is rho a v square sin theta cos theta. So you have to remember the three formula. Fn is equal to rho a v square sin theta, fx is equal to rho a v square sin square theta, and fy is equal to rho a v square sin theta cos theta for inclined flat plate, stationary flat plate. But here you have to take care of angle theta. So this angle theta you should note very carefully. It is the angle between the jet and the plate. Sometimes you are giving the angle between the jet and normal to the plate, so that angle is also given sometime as a theta. Then this formula, when you are going to apply, this formula will be for the angle which is made by the jet with the plate, not with the normal to the plate. So if it is given as an angle normal to the plate and the jet, then you have to take this angle as a 90 minus theta and put that angle as a theta, which is coming after calculation. That angle you have to put in this formula. So you have to remember this formula for the angle between the jet and plate. Okay. So let us see one numerical on the case number 2, that is a jet of water of diameter 75 mm moving with velocity 25 meter per second strikes a fixed plate in such a way that the angle between the jet and the plate is 60 degree. Find the force exerted by the jet on the plate in the direction normal to the plate and in the direction of the jet. So it's a very straightforward formula. Diameter is given 0.075 meter, area you can calculate pi by 4 d square, velocity of the jet is given 25 meter, and now specifically the angle between the jet and the plate is given as theta as 60 degree. So it is straightforward angle is given as 60 degree. Sometimes the angle is given between jet and normal to the plate, so you have to take care. So Fn is calculated by the formula rho a v square sin theta, and rho a v square sin theta will give you theta you take as a 60 degree, and if you put all the values you will get Fn as 2390.7 Newton and Fx you will get as by the formula rho a v square sin square theta. So you know Fx is equal to 1000 into 0.004417 into 25 square into sin square 60 will give you the Fx, that is force in x direction, as 2070.4 Newton. So the basic thing in case of inclined plate is that you have to remember the three formulae. That is, the force in normal direction is given by rho a v square sin theta, force in x direction is given by rho a v square sin square theta, and the force in y direction is given by rho a v square sin theta cos theta. So simply you have to remember these three formulae. So up till now we have seen the two cases only. First is the flat vertical stationary plate for which you are calculating Fx, that is Fx is nothing but the normal force. In that case it is simply given by rho a v square, while for the case number 2 you are having three components Fn, Fx and Fy. So the formula you have to remember accordingly. Fn is rho a v square sin theta, Fx is rho a v square sin square theta, and Fy is equal to rho a v square sin theta cos theta. Thank you.